Now dividing decimals, though. So the general strategy for dividing decimals, and we do usually use long division, okay? But one thing that we need is for the divisor, let me make sure I'm using the right one. Yeah, the divisor to have no decimals. We don't really care if the dividend has decimals or not. It's the divisor that makes it real difficult. So what we're going to do is we end up moving the decimal in the divisor to the right until it becomes no decimal, okay, or until it shows no decimal. But if we do it to the divisor, just like we've talked about with the equivalent fractions, we have to do it with the dividend as well. So, and just so we remember, the divisor is the second number in the division problem, right? So, for an example, 4 divided by 8, 4 is the dividend and 8 is the divisor, okay? So, if this was like 8.8, that's the divisor. That is where we run into the problem. If it was 4.3 divided by just 8, that's not a problem. We can use long division with that. But as soon as it becomes 8.8, that's where we need to change that 8.8. And again, we would say, well, I'm going to move this decimal 1 to the right. But if I do it to that number, I've got to do it to the other number as well. Because this is really a fraction, and if I'm going to sell the denominator, or in this case the divisor, then I have to do it with the numerator as well, or the dividend. Okay. Otherwise, I've changed the value of the fraction. And then we use long division by keeping the decimal in the same place. We'll expand on that more in here in a second. But just remember, again, when operating with negatives, all the basic operation rules apply. Okay. So this one's nice. We got 2 positives. And again, we don't want that 3.1 to have a decimal. I don't care about the 17.67. I just want the 3.1 to have no decimal. So what do? Well, I'm going to take that 3.1 and I'm going to move the decimal 1 place value to the right to make it 31 instead. But again, if I do it to that number, I've got to do it to this one as well, which would then make it 176.7. Now, I will clarify, we are able to move the decimal because all we're really doing is multiplying the two numbers by 10 in this specific case, or we're multiplying them by base values of 10. So that allows us to move decimals, again, for both of the numbers. So I don't have a decimal now, what I've written in blue here, with the divisor or the denominator, okay? So I can move straight into long division, which would show 176.7 divided by, now, 31. Well, with long division of decimals, we're going to keep that decimal place value where it is. So I'm just going to move it straight up into the quotient. And I would divide this as though there was no decimal now, okay? Because wherever the place values go is where they go. So what I mean by that is I look at the 31 and I say, well, 31, it won't go into 1. It won't go into 17, but it will go into 176. How many times will it go into 176? That should be 5. 5 times 31 is going to be 155. Yeah. So I subtract that now. I get a 1 there and a 2. All right, now again, I'm not worried about the decimal. It is where it is. The 5 goes over the 6 as the quotient because I looked at it just as the 176. So I'm going to need to drop the 7. Okay. Well, now I have 217. How many times will 31 go into 217? Should be 7 times. So 7 times 31 is actually 217. So I have a 0 remaining right there, which is good. If I did have a remainder, that would be fine. I would just plug a 0. I would take the next place value, which is the hundredths. I would make it a 0 because there is a 0 there. It's a phantom 0 now, which we're showing. And then I would drop it to make, in this case, 2 zeros. But that makes that number bigger to work with whatever divisor you're working with. But in this case, we're finished with the 5.7. But again, I would go to the calculator and check 17.67 divided by 3.1. We should get the same answer, 5.7. So if we looked at this, let's look at this as a fraction, right? So I had 17.67, and it would have been over 3.1 like this, right? Well, I what I've done is I've really created an equivalent fraction, which means the division is the same, and I just made the fraction 176.7 over now 31. I haven't changed the value of the fraction. All I did was I changed how it looked. So since the fraction is equivalent, I chose to work with this one instead of this one, which means that I do not need to change or move the decimal back, kind of like we did with the multiplication, right? It was like, well, how many decimal places are there? I'm not really worried about how many decimal places there are as much as scaling this fraction into being something easier to work with like this one. Yeah, to address that, like let's say that we didn't move the decimals, okay? So let's write this problem out. Long division, right? Well, 17.67 divided by 3.1. Now here's where this becomes a problem. Is I'm looking at 3.1 instead of 31, right? Well, how many 3.1s are in 17? I don't know, 5 maybe. The problem with that is I still get a decimal value out of that. So, I mean, it's like, well, it goes into it 5 times, and 5 times 3 is 15, and then 0.5. So, I mean, and maybe that still kind of works that way. It's just sometimes it's hard to look at this if there's other values to the left of it. Like this one seems like it works out pretty well. But if I said, well, how many 3.1s are in, even if I looked at 17 right there, well, I said 5, and we got the 15.5. It just may be harder to comprehend this 15.5 as opposed to the 155 because I don't remember if we were able to do this, but I'm not sure that the decimal just going straight up like we used in this method really applies in this case. If we end up with a decimal like the 3.1, if there were more decimal place values, instead of moving it one place, you could end up moving it more places than just one. So, but again, if you're moving this more than one place, then you'd have to move the one, you'd have to move this one also more than one place, right? It's just, they need to match, however many times you move a decimal for one of the numbers, you also need to move it the same number of times for the other one. Right, like this other one, if we did that, it'd be 2.17 right there. Well, then it becomes a question, well, how many 3.1s are in 2.17? For a decimal value, for me, that's difficult. But if I were to look at this as whole numbers like we did up here, it becomes 217 and 31, which I do know. I say, well, I know 31 goes into 217 7 times. Whereas this case, you'd actually have to think about it as 0.7 instead. So and that's why we teach it this way, is because hopefully it's easier to comprehend and even to work with on that. So yeah, we did that example. You guys try this one, and we'll go over it. We'll give you guys 1 minute, all right? 1 minute, go. All right, guys, let's go over this. Hopefully that was enough time. Well, the first thing I guess I noticed on this one is that there's one negative, which means our answer is negative. So we'll get that out of the way. And then this division stuff. So I don't want that 8.9. I would really like that to not have a decimal. So if I move it one place value to the right, I got to move this one also one place value to the right. which makes this 231.4 divided by 89. So now we can use the long division on this. 231.4 divided by 89. Let's see how this turns out. So 89 won't go into 2. It won't go into 23, but it will go into 231. Let's see, it should be twice, I guess. 2 times 89. Again, I'm going to move that decimal there. 2 times 89, that'd be 178. So I subtract, what do I get? I'm going to borrow 3, make that a 12 as well. 553, all right. And then I'll drop the 4 to make that 534. Well, 89 will go into 534. Let's see, not 6 times. Oh, maybe it is 6. Anything? Okay, well, let's see. 6 times 9 would be 54. And then 6 times 8, 48. Oh, it is. Well, that worked out pretty good. So 0 remaining right there, 2.6. Now remember, I got my negative up there. So we'll just write it as negative 2.6. I got that typed into the calculator. Let's just double check. Negative 2.6, and we're good. It worked out pretty good. All right, and you may see some division with the fraction like this. It's still division though, okay? And again, I notice this is negative. So whatever I get for my answer is just going to be negative. Now, if we were to write this as a division problem, 1.38 divided by 6, it's showing the divisor as a whole value, 6. Or the denominator is already a whole value, the 6. Which means I can go straight into my long division. So I got 1.38 divided by 6. Well, 6 won't go into 1. And again, we're just moving the decimal up. So I'm going to show the 0 there to hold that place value. But 6 will go into 13 2 times. 2 times 6 is 12. So I subtract that, I get 1. I'll drop the 8 to make that 18. How many times will 6 go into 18? 3 times. 3 times 6 is 18. So I get 0 remaining. And so that gives me my final answer. Again, we got that negative 0.23 or negative 23 hundredths. All right, divide this round to the nearest hundredth. Okay, well, let's go and divide this. We'll just remember to round to the nearest hundredth. And I can see I got 2 negatives being divided. So I know my answer is going to be a positive. But I got that 0.06. I don't like that decimal, right? So I need to change this into a whole value. I'll just move both decimals 2 times to the right, which is going to change this to 397 divided by 6. Well, that should be a lot easier to work with. 397 divided by 6. Well, for 6, how many times will it go into 3? None. But it will go into 39 6 times. 6 times 6 is 36. Subtract, get 3 there. So we'll drop the 7. How many times will 3 go into 37? Well, another 6 times. So 6 times 6 is 36. Got to subtract. I got a remainder of 1 there. Now, I got a remainder of 1. It said round to the nearest hundredth, which is okay. But right now, I'm not showing any decimal places. In fact, I didn't even have a decimal in the long division part of this. Well, there is a decimal. It's just not showing, you guys. It comes after the 7 right there. And what I can do is I can tack on a 0 in the tenths place and drop it to make that 10. Now remember, the decimal needs to go in the quotient where it is in the long division. So it just goes straight up from where it is in the numerator or the dividend. So I got 66 point something, and now I got a 10 to work with instead of just 1. How many times will 6 go into 10? 1 time. So 1 times 6 is 6. I got to subtract there. It's 4. Well, 4 is no good. But if I make it 40, that's going to work. So again, I've tacked on another 0. And we'll only go so far in this one. How many times does 6 go into 40? Let's see, 6 times. Okay. 6 times 6 is 36. Subtract and I get another 4. So I'm going to drop a 0. And yeah, some of you guys already know what's happening. You see, if I were to look or work from here, yes, I'd have to have another 6 right there, right? And that gives us another 36 and another 4. And then this process at this point starts to repeat this way. Well, this is really as far as we needed to go because it said to round to the nearest hundredth. So for rounding, look to the place value you're rounding. Look, underline it. What did it say? Underline. Look to the right. If it's 5 or more, which is this case, then add 1. Yeah, I'm way off on the rhyme there. Again, I don't have those songs memorized. But maybe you will after you watch enough YouTube. Okay, so let's go back to the number here. 66.166. So I looked at the hundredths place value. I looked 1 to the right. It's 5 or more, so I add 1 to that place value. And I end up with 66.17. Again, that's rounded. But let's just go back to the calculator and check. Now, the calculator shows a 7 at the end of that number. Okay, that's because it's saying, look, there's a lot of 6s after this. I'm just going to round it to this place value because I can't show you any more. So even though it's 66.1666666, a bunch of 6s and a 7, right? Again, we would just look at the 1 6, and the next 6 makes that 6 in the hundredths place round up to a 7. So even though it hasn't rounded for us, we can hopefully do that from here. Now, if you wanted to change it, you could go into mode, and I think it works the same way. For us, it's float, and I think it's 2. We want 2 decimal places. So I push enter. Now I come out and I type that in, and then it rounded 2 decimal places for me, which is the hundredth. So it confirms, using this mode stuff business, that 66.17 is correct. Now, I don't really want it to do that all the time, so I'm going to go back into my mode. I go to float. I just want it to float all the time, so I'm just going to write float and keep it that way. All right. This one's going to turn out pretty good, okay? I like these types of problems, and I'll get to why here in a second. Let's apply our process to this, though, okay? So the first thing I would do, I don't want one, what is that, 10,000? So I'm going to move that decimal to make it just 1. 1, 2, 3, I have to move it 4 times. Well, I've got to move it 4 times for the dividend as well. Now, there's this empty space here. I'm just going to fill it in with 0. To hold that place value, which makes this now, what is that, 868,460 divided by, and this is where it becomes really nice, 1. And what do we know about division by 1? Anything divided by 1 is itself. So this ends up being 868,400. That was pretty nice. If you want to put the comma in, that's fine. And yeah, we could check on the calculator. Let's do that. I just wrote my 6 really poorly. Maybe I said 400. It's a 6 right there. That's better. Again, that's another copying error I did today. That's be careful on that stuff, okay? Let me reemphasize the 0 thing on this case. So the 0 right here, like if we wanted to, it was a decimal originally. So whenever there's zeros following values in decimals, we don't usually show them if it's only zeros. So even though the 0 wasn't showing before, it was there. We just didn't really need to show it because it's just a bunch of zeros going on forever. So in order to make our life a little bit easier, we don't show that 0 until we need it. All right, now some applications with division. A case of 7 items costs $7.49 at Sam's Club.
Hey, Sal.
All right, a case of 7 items cost they're $7.49. So I mean, it's asking what is the price of each item, right? So, and yes, we do get to assume that all the items cost the same. It didn't. I suppose it didn't really say that the items were the same. Okay. But we get to assume that they cost the same. So maybe it's just one case. I don't know. Yeah, it is a case. That's good. So we're gonna take what's the price of each item, or what's the price for one item, right? Now, I think. So we're just gonna take that $7.49, and we're gonna divide it by 7 items. Okay. So 749 divided by 7, well, this is already, the divisor is already whole numbers, so we don't need to worry about moving the decimal here. Well, actually, there's an application, so I'm not even going to do the long division. I would just take 7.49 in the calculator and divide it by 7. And we get 107. That's pretty good. So if this was a case of whatever item this is, 7 items at $7.49. Each item would be $1.07. That's it. And again, it's more about, because like if we saw something like this on a quiz, we would just want to know what operation we're using, right? And we've gone over 4 operations: addition, subtraction, and multiplication, now division. And if it's in a section like this where it's labeled division of decimals, that's not too hard to realize that we're using division, of course. And we may wonder, well, which comes first? Well, since it's asking the price of each item, it's really asking how many dollars per one item. So, and we'll get into this more in detail later, but it's $1.07 per item, like if this was a fraction. I mean, it reads $1.07 per item, which again is a fraction. So I don't know, maybe I'm not explaining that very well, but another way to look at it is just the very foundation of what division is, and that's how many times something goes into another. So this one would be asking how many times 7 goes into $7.49. And again, that would tell you how many dollars one item is.